Today we're exploring into how someone might access an Android device using the Metasploit Framework within Kali Linux. This method can exploit vulnerabilities in Android apps, particularly when a user unknowingly installs a malicious APK file. We'll go through how these attacks work and discuss the process step by step. But first, if you are a new user here, please subscribe my channel and press the bell icon. Also meet me. This is your friend Saoz, IT specialist and member at web development. For example, you receive an APK file for an Android app, maybe through a phishing message or a sketchy link. When this APK is downloaded and installed, it can allow the attacker to control the device remotely. Using Kali Linux and the Metasploit framework, attackers can create these types of files to open backdoors in Android devices. The method we're talking about targets Android operating system versions vulnerable to certain bugs, like CVE 2000-27384. In simple terms, this vulnerability lets hackers slip a hidden program into the APK, which, once installed on the Android device, allows them remote access. Create a malicious APK file. First, in Kali Linux, an attacker uses Metasploit to create a harmful APK file. This APK can look like a regular app, but it's actually hiding software that lets the hacker control the Android device. Send APK to target device. Once created, the hacker sends the APK file to the target device, usually through phishing tactics or social engineering methods, tricking the user into installing it. Gain remote access. Once the APK is installed on the Android device, it establishes a connection back to the attacker's system. This gives the attacker control over the device, allowing them to view data, access files, or even control the camera and microphone. In this part, we'll go through how to set up and run an exploit on an Android device using Kali Linux's Metasploit. Here's what happens step by step. 1. Configuring the lhost. Before we launch the attack, we need to set the lhost, localhost, in Metasploit, which is the IP address that our attacking system will use. Since we're working in a Kali Linux virtual machine, VM, we set lhost to the IP address of this VM. With this set, the exploit is ready to be launched. 1. Generating a malicious APK file. Using Metasploit, we create a malicious APK file by typing specific commands into the terminal. This APK will act as the backdoor that, when installed on the target device, lets us take control. The file is stored in the /var/www/html folder, so it can be easily shared. 1. Serving the APK file. To get the APK file to the target device, it has to be shared over the internet. We start a simple web server, like Apache, on Kali Linux, which hosts the APK so the target device can download it. This is often done through social engineering, like sending a fake link to the user. 1. Setting up the exploit in Metasploit. Back in Metasploit, we set up the payload, the malicious code that will run once the APK is installed on the Android device. We confirm all settings, including lhost and lport, the listening port, to prepare for a successful connection. 1. Running the exploit. Once everything is configured, we simply run the exploit command in Metasploit. This starts the process, and if the target device installs the APK, we gain access. We can now monitor the device, access files, and potentially control different aspects of it. In this part, we'll explore how hackers could access Android devices using the Metasploit framework from Kali Linux. I'll break down the process in simple terms to show you how malicious APK files work and what attackers might do once they gain access. Remember, this is purely for educational purposes. It's important to understand these techniques to improve security and defend against similar attacks. Understanding the attack process. To start, attackers create a malicious APK file that looks like a regular app file you might install on an Android device. This file, once opened by a target, initiates the attack. The victim, unaware of the malware, installs the APK, and once that's done, the attacker gains control of the device remotely. The steps include embedding harmful scripts into the APK. These scripts then install malware that enables the attacker to control various aspects of the phone, often without the user's knowledge. This might include data access, microphone and camera control, or even GPS tracking. 1. Creating the malicious APK. Using Metasploit on Kali Linux, attackers first generate a malicious APK file. They can customize the payload to do specific things on the victim's device once installed. 1. Tricking the user. The malicious APK file is typically sent through a link disguised as a legitimate app or a helpful download. When the user clicks the link, the APK downloads to their device, often without raising any security warnings. 1. Establishing connection. Once the user installs the APK, it silently connects back to the attacker's Metasploit console on Kali Linux. This connection allows the attacker to issue commands to the Android device remotely. 1. Command and control, C2. With control established, attackers can run various commands, enabling them to access files, activate the camera or microphone, read SMS messages, track location, and more. Once the attacker has control, they can perform several actions, including core commands. Basic actions like reading files, listing processes, or taking screenshots. File system commands allows attackers to access, copy, and delete files. User interface commands interact with apps, open and close windows. Location tracking obtain GPS coordinates to monitor the victim's location. System commands change settings or reboot the device remotely. Noted, each command provides valuable information that attackers can exploit to understand the victim's activity, gain further access, or steal sensitive data. Trojan horse viruses, often embedded within malicious APKs, are frequently used for these types of attacks. For instance, a well-known banking Trojan would disguise itself as a legitimate app, steal login credentials, and relay sensitive information back to the attacker. Attackers can also use drive-by downloads, where simply visiting a compromised website can trigger a download. Once the malware is on the Android device, it can run silently in the background, gathering data or granting remote access. Hackers use Kali Linux to create malicious apps. This powerful operating system is a favorite among cybersecurity professionals and hackers alike due to its extensive suite of tools designed for penetration testing and security research. Kali Linux is an operating system designed for penetration testing. It comes pre-installed with hundreds of tools that can be used to test the security of networks and devices, making it an ideal platform for both ethical hackers and cybercriminals. It has tools that can create Android package kits, or APKs. These APKs are the files that install apps on Android devices, and they can be crafted to include malicious code. APKs are files that install apps on Android devices. When a user downloads and installs an APK, they are essentially adding a new app to their device, which can be either legitimate or harmful. The process starts with Metasploit. Metasploit has a payload. This payload is a piece of code that can perform various malicious activities once it is executed on the target device. This payload is a piece of code. It is designed to exploit vulnerabilities in the target device, allowing the hacker to gain unauthorized access and control. It runs on the target device. Once the payload is executed, it can perform a range of actions, from stealing data to installing additional malware. The payload can do many things. It can monitor the device's activities, capture sensitive information, or even take control of the device's functions. It can open a backdoor for the hacker. This backdoor allows the hacker to access the device remotely, bypassing any security measures that may be in place. The hacker embeds the payload into an APK. This process involves modifying the APK file to include the malicious code, making it appear as a legitimate app. This creates a malicious app. When the user installs this app, they unknowingly grant the hacker access to their device. This app looks and acts like a normal app. It may function as expected, providing the user with the features they were looking for. But it secretly runs the hacker's code. This hidden code can perform malicious activities in the background, compromising the security and privacy of the user. Once the malicious APK is created, it needs to be delivered to the target. Hackers use various methods for this. They might send you a phishing email. This email will trick you into downloading the app. They could disguise the app as something legitimate. It could look like a game or a useful tool. They might even hide the app on a website. You might accidentally download it. Social engineering plays a big role. Hackers are good at tricking people. They might use urgency or excitement. They want you to install the app without thinking. Once the malicious APK is installed, it runs the payload. This payload connects back to the hacker's computer. This connection is called a reverse shell. It gives the hacker remote access to your device. The hacker can now control your device. They can steal your data, they can read your messages and emails, they can even track your location. This is a serious breach of privacy. It is important to protect yourself. Be careful about the apps you install. Only download apps from trusted sources. Section 6, Step-by-Step Guide. Exploiting Android devices with Metasploit. In this section, we will walk you through the detailed process of exploiting Android devices using the powerful Metasploit Framework. Let's look at the steps involved in exploiting Android devices with Metasploit. This guide is designed to provide a comprehensive understanding of the process, ensuring you grasp each step clearly. This is for educational purposes only. Our intention is to educate and inform, not to encourage any illegal activities. Do not use this information for illegal activities. Misuse of this knowledge can lead to severe legal consequences. Open Metasploit and set LOST to your IP address. This is a crucial step as it tells Metasploit where to send the connection, essentially pointing the target device back to your system. This tells Metasploit where to send the connection. Ensuring the correct IP address is set is vital for the success of the exploit. Use the msfvenom command to create the malicious APK. This command allows you to generate a payload that can be embedded into an APK file, which is the format used for Android applications. Select a suitable payload, such as Android/meterpreter/reverse_TCPI. This payload is designed to create a reverse connection from the target device back to your system, giving you control over the device. Use a tool like Python's simple TTP server to host the APK on your system. This makes the APK accessible for download by the target device. Select the corresponding exploit for the chosen payload. This step is crucial as it determines how the payload will be delivered and executed on the target device. Configure the exploit with the necessary options, such as LOST and the port for the reverse connection. These settings ensure that the exploit is correctly set up to communicate with your system. Initiate the exploit and wait for the target device to connect. Patience is key here, as it may take some time for the target device to establish a connection. Once connected, you will have a MeterPreter session granting you remote access. This session allows you to execute commands on the target device, giving you control over its functions. Remember, these steps are for educational purposes only. The knowledge gained from this tutorial should be used responsibly and ethically. Using this information for illegal activities is a crime. Always ensure that your actions are within the bounds of the law and ethical standards. Section 7. Real-world dangers, the impact of Android exploits. Android exploits have real-world consequences. Hackers can steal financial information, they can access personal data, they can even spy on individuals. There have been many cases of Android malware attacks. These attacks can target individuals and organizations. They can cause significant damage. These attacks highlight the importance of cybersecurity. We need to be aware of the risks. We need to take steps to protect ourselves. If you're wondering whether your Android device has been compromised by Trojan horse malware, here are a few key warning signs to watch out for. Device slows down or crashes frequently. Is your phone or computer acting up more than usual? If it's slowing down or crashing without explanation, it might be a sign of malware. Strange behavior. Pay attention to unusual activity, like random apps running on their own or your battery draining faster than usual. This could indicate that malware is secretly using your device's resources. Pop-ups and spam. Are you bombarded with spammy notifications, unwanted pop-ups or ads? If this is happening, it might be malware causing these interruptions. Here are a few steps to protect yourself against Trojan horse malware. Download apps carefully. Only download apps from trusted sources like Google Play or the official website of the app. Avoid clicking on unknown links or attachments. Don't open attachments or links from people or websites you don't trust. They might contain malware. Install antivirus. Software, a reliable antivirus app, can detect and remove malware and will help keep your device safe. Ethical hacking. Using your powers for good. The techniques used by hackers can also be used for good. Ethical hackers use their skills to find vulnerabilities. They report these vulnerabilities to developers. This helps make systems more secure. Ethical hacking is a growing field. It plays a vital role in cybersecurity. By understanding how hackers operate, we can better protect ourselves. If you are interested in cybersecurity, consider learning more about ethical hacking. It is a rewarding and challenging field. Section 11, Conclusion, Navigating the Mobile Threat Landscape. The world of mobile technology is full of possibilities, but it also comes with risks. Android exploits are a serious threat. They can compromise our privacy and security. By understanding how these exploits work, we can better protect ourselves. We need to be aware of the risks. We need to take steps to mitigate them. By staying informed and taking precautions, we can enjoy the benefits of mobile technology while minimizing the risks. See you soon in the next video. Take care.